At 4 p.m. Sun time, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. NASA engineers have re-established communication with Voyager 1, Earth's most distant emissary, after months of troubleshooting a glitch that had rendered the probe's transmissions unreadable. What shocking discovery has NASA's Voyager probes made after 45 years in orbit? Despite having little memory and sluggish data rates, these 1977-launched spacecraft have been at the vanguard of interstellar research for a considerable amount of time, but Voyager 1 has recently returned data that has scientists puzzled and worried. Information about the control system is inconsistent with how it is now operating, suggesting an impossibility. Come along with us as we explore the universe to solve this riddle. On September 5, 1977, Voyager 1 was launched into orbit from Cape Canaveral, Florida, using a Titan IIIe Centaur rocket. An incredible trip had begun with this. On August 20, 1977, 13 days prior, Voyager 2 began a corresponding space mission, starting a parallel trip. Their primary objective at first was to investigate the moons of the gas giants Jupiter and Saturn in our solar system. These brave adventurers far exceeded their original objectives by embarking on a trip that would lead them to the furthest reaches of our cosmic neighborhood. Voyagers 1 and 2 have broken many records during their historic mission, having outlasted every previous spacecraft in history. They have flown farther from Earth than any other human-made object in interstellar space. These are the first objects created by humans to explore portions of the galaxy that are yet unknown to science and beyond the influence of the Sun. Scientists have gathered an immense amount of priceless data. These groundbreaking interstellar probes are located more than 12 billion kilometers from Earth, and their discoveries never cease to astound physicists. We'll talk more about one amazing and unanticipated discovery later on that scientists could never have imagined. The twin probes of Voyager have accomplished amazing things throughout the years. Over 40 years ago, they made the astonishing discovery that there were moons on Jupiter and Saturn, shocking scientists and upending their preconceived assumptions about these far-off planets. These moons turned out to be throbbing with geological activity, defying earlier theories that they would be dead and cratered like our own moon. Particularly during its voyage, Voyager 2 accomplished a number of noteworthy milestones. As the first spacecraft to sail past Uranus, it made history in 1986. That was the sole spacecraft to fly past Neptune, having done so 3 years later. From Neptune's ferocious winds and icy volcanoes on Triton to the hitherto undiscovered moons of Uranus, this amazing voyage provided a plethora of knowledge about these far-off ice giants. NASA has implemented multiple procedures aimed at extending the spacecraft's operating lifespan. While it continues its amazing voyage, by turning off heaters and non-essential parts to save energy, the spacecraft will continue to operate far beyond the next 10 years. Since the Voyager mission is planned to conclude in 2030, this meticulous management guarantees that they will be able to continue returning data as long as possible. For the scientists and engineers who have been involved in this amazing journey from the beginning, the Voyager mission's end is a moment of mixed emotions. It was discovered that Io, a moon that is marginally bigger than Earth, is the solar system's most volcanically active body. Our knowledge of these far-off planets has changed as a result of the Voyager research of their moons and outer planets. The astounding discovery that Europa, the moon of Jupiter, may have an ocean beneath its frozen surface sparked curiosity about the possibility of extraterrestrial life. Similarly, the finding of geysers flowing from Enceladus, the moon of Saturn, indicated the possibility of liquid water beneath the surface of the planet. These results have motivated follow-up missions to learn more about these fascinating moons and have significant implications for the hunt for extraterrestrial life. The experiences that Voyager 2 had with Neptune and Uranus were equally revolutionary. During the probe's approach to Uranus, it was discovered that the featureless blue-green planet had many moons, including the fascinatingly active Miranda, and a complicated magnetic field. Humanity received its first detailed photographs of Neptune in 1989 when Voyager 2 passed close to the planet, revealing its vibrant atmosphere, deep blue color, and great dark spot. In addition, the spacecraft confirmed that there are weak rings surrounding the planet and found 6 additional moons. The Voyager's equipment continued to send back important scientific data as they traveled farther into space. Crucial data regarding the heliosphere, The bubble-shaped area of space dominated by the Sun's magnetic field and solar wind was supplied by the probe. The Voyagers were able to investigate the interstellar medium, the sparse environment between the stars, after passing through the heliopause, which marks the edge of the heliosphere. The unexpected rise in cosmic rays found in interstellar space is one of the most astonishing recent findings from the Voyager probes. This discovery has caused scientists to reconsider their theories about the interstellar medium and the environment beyond our solar system. The information gathered by the Voyagers on magnetic fields, plasma waves, and cosmic rays is still very helpful in understanding the composition of interstellar space and the mechanisms forming our galaxy. The longevity and success of the Voyager missions are a testament to the creativity and dedication of the scientists, engineers, and technicians who designed, built, and operated the spacecraft. The Voyagers have persevered in operating despite the extreme conditions and great distances they have traveled, returning data that has revolutionized our knowledge of the solar system and beyond. The missions have also brought attention to how critical robotic exploration is to advancing our understanding of the cosmos. NASA has put policies in place to preserve the Voyagers' remaining energy and prolong their missions as long as feasible. As they get closer to the conclusion of their operational lives, the spacecraft are anticipated to survive until at least 2030 if they carefully manage their energy supplies and shut off non-essential systems. Our knowledge of the interstellar medium and the outermost regions of the solar system will be considerably enhanced by the data they return during this period. Beyond their contributions to science, the Voyager missions leave behind a lasting legacy. Each spaceship is equipped with the recognizable golden records, which are audio and visual records that showcase the variety of life and civilization on Earth. These documents are a message to any future extraterrestrial civilizations that could come across the spacecraft. The golden record's presence reflects humanity's interest in and desire to establish connections with the larger cosmos. The Voyager spacecraft's breathtaking images confirmed the odd signals picked up from Io. These photos showed a dynamic terrain characterized by towering volcanic plumes and the discharge of volcanic debris. Pele, a well-known volcano on Io, is one of its most spectacular characteristics. Its eruptions have reached heights 30 times higher than those of Mount Everest, erupting across an area about the size of France. More than 33,000 images of Jupiter and its moons were taken by the Voyager spacecraft, demonstrating the grandeur of the planet and the remarkable diversity of moonscapes in the Jovian system. A mission far more successful than anyone could have imagined has resulted from their commitment and tenacity. Many scientific advances and significant new understandings of our solar system and beyond have resulted from the data that the Voyagers brought back. Future generations of scientists and space enthusiasts have also been inspired by them beyond our wildest expectations. Before their launch, the Voyagers have experienced and captured the wonders of our solar system. These missions have revolutionized our knowledge of these celestial worlds, revealing secrets like the frozen shell of Europa, the towering volcanic plumes on Io, one of Jupiter's moons, and the amazing discovery of Jupiter's thin rings. Previously believed to be lifeless and desolate, the amazing pictures and data they returned showed lively and active worlds. New questions emerged as Voyager 2 traveled farther and encountered Neptune and Uranus, highlighting the richness and complexity of our solar system. System's outer planets were the finding of 10 hitherto undiscovered moons around Uranus and the harsh weather on Neptune, where winds might reach 1,000 miles per hour with surface temperatures down to -391 degrees Fahrenheit (-235 degrees Celsius). Triton, the biggest moon of Neptune, was discovered to be among the solar system's coldest locations. Other surprising discoveries included the ice volcanoes of Triton, which released frozen particles and nitrogen gas. As Voyager 2 carried on its extensive exploration of the outer planets, Voyager 1's trajectory brought it dangerously close to Saturn's moon Titan, exposing its hazy orange atmosphere and intricate chemistry. Many new concerns concerning the nature of these far-off worlds were raised by each encounter, which yielded a plethora of data that challenged preconceived notions. Ordinary spacecraft were not what Voyager 1 and Voyager 2 were. Their precise design called for them to be stable platforms, rotating at a rate that is over 15 times slower than a clock's hour hand. Because of its design, there was less visual blur as the spaceship was speeding through space and taking pictures and data. Even before they encountered the outer planets, their astounding imaging skills started to amaze scientists and the general public. While still several months away from Jupiter, the spacecraft began to transmit photographs of the planet. The gas giant's whirling clouds and recognizable Great Red Spot were seen in these early photos, which thrilled viewers at NASA's Jet Propulsion Laboratory. But the real catalyst for the Voyager's groundbreaking observations was the finding of active volcanoes on Jupiter's moon Io.